This is a week 6.2 Max Pat, so please open this up and follow along. We're going to cover a number of important objects: the QList object, the sequence object, the MIDI format and MIDI parse objects, and then finally the detonate object. And we're going to start with the QList. This is QList here. It can take an argument, which is just a name that identifies the QList. That name is necessary. It's really just for your own reference purposes. QList, even though it's spelled QList, is actually a CUE QList. In other words, it's a list or a collection of cues that can be sent during a performance. So the QList came about because composers wanted to be able to post events into the future rather than simply having every event having to be triggered by something. The idea was that we could create a cue and you could say, let's do this action now, and let's wait a second and then do this action, wait 5 seconds and then do this action. And rather than having to actually trigger each of those actions, you set the cue list running, and the cue list looks after, once you start it, of scheduling those events in the future. So a very useful object. Like the call object, it is a text edit that you create. And I'm going to open up this one by double-clicking it, and you can see a cue list. And the cue list has you can see that there are some lines which have a word followed by numbers and other lines which just have numbers. And you'll also notice that every single line has a semicolon at the end of it. So, so this one says var1 25. And what that means is send a message 25 to a receive called var1. And so if we look on this patch, you'll see, yes, there's a var1 here, a var2 there, a var3 here. The var3 is connected to a line, so it's actually expecting two values, a destination and a duration to get there. And then we've also got one here called note, receive note. So everything we put in the cue list must correspond to a receive somewhere in an open patch for it to work. If it doesn't have that, if the receive doesn't exist, it'll generate a message, an error message. The lines that have only a number are considered to be delay times. So this 1,000 simply means after we start this cue list going and we've sent 25 to the var1 receive, we're going to wait 1,000 milliseconds, and then we're going to do a bunch of other things, sending this value to that, sending this value to that, sending this value to that, and then we're going to wait 2,500 milliseconds and send these values. So anytime there is a number with just a semicolon after it, the cue list considers that a wait for that amount of time. And anytime there is a receive name as the first element there in the line, then the cue list will send that value to the receive. Okay, so that's essentially how it works. Let me just pull this over so we can see both of these at the same time. And I am going to start this cue list running by sending it a bang. And this bang tells us the cue list is done. But this bang is going to start the cue list going, and the cue list is going to do all of the actions in there. So you're going to see var1 getting a value of 25, and then 2 seconds later, it's going to get a value of 45. And then these other ones, var3 is going to get a value of 100 and 2,000. So it's going to go up and so on. All right, so let's just watch this all sort of happening. Okay, so those are all the actions. I'll do it one more time so you can see everything happening. Okay, and if we were to add another element in here, let's say note 72, 100, 1,000, semicolon. save that, open it up again. And then we get the note at the end. Okay. We can also, rather than just having all of this done automatically, we can rewind to the top of the cue list, and we can go to each of the events one at a time. So I did a rewind comma next to get to the first element, the first message in the queue, the first queue. Then I go next, and it will do the next block of messages, and then the next block of messages, and then the last block of messages, these three. So in other words, what it's doing is it's performing the cues until it hits a number, and then it's just stopping there. And then when I hit next, it skips over the number and it performs the next block of operations. All right, so that's cue list. Let's open this one up. And you can see that this has got a whole bunch of the note messages, which has got the word note, which means send to receive note, and then a list. Then it's got some delay times. So we can play this. Maybe I'll leave it open. I could also rewind it to the top and do the first note. And basically step through it in my own time, ignoring all the delay times that are in there. So I can do it both in a sequence of events which are all timed, or I can do them as a series of events that I want to, when I'm ready to do it, I just go to the next cue. You can also there are a number of things you can do. You can actually change the tempo of a cue list so that the durations are not necessarily milliseconds. And there's actually a lot of things you can do with the cue list. Most of the time, you create cue lists by just simply typing the cue into a text box and hitting save when you're done editing it. But it is also possible to create cue lists programmatically. It's a little bit tricky. Actually, it's a lot tricky because you have to use the append, the word append, and then you say what you want to append to the cue list. But you've also got to make sure that you're able to append the semicolon at the end. So, I mean, you need to say something like this: append note 57 100,000, and then the semicolon. But in order to put a semicolon, you need to put a backslash semicolon. And so if you put a message like that in to this cue list and then open it up, it is actually appended that message to your cue list. So it's a tricky thing to do this programmatically. You would have to do, maybe I'll show you because it's a sort of tricky thing. If I had a pack which had the word note 60, 100, 1,000, right? I'm just going to put a message in here of, let's say, 60. Doesn't matter what it is. This message is going to go in, and it has to go not into the note. It needs to go into the 60, and then it also needs to bang the pack out. And that will give me a message which says, you'll see, it gives me a message which says, note this. Then I need to append the word, actually, I need to prepend the word append to the beginning of this list. so that now it says append that note. So the prepend will put something at the beginning of a list. And then I need to append the backslash semicolon to the list. Oops. Doesn't want to let me do that. Try this. No. That works. There we go. So let's put that into the queue list just to see what happens. Do it a bunch of times, and we actually have a bunch of notes that have been added. Okay, so this is the way to do it. A note, 60, 100, 1,000. Add the semicolon as another element in the list, and then prepend and append onto that. Okay, so not the easiest thing in the world to do, but it is possible with a little bit of fussing around to be able to add a element to the queue list. If you want to add just a duration, you're going to have to put the duration and also a semicolon. So you're going to have to add a list of 2 things to that. Okay. If you need more help, let me know. If you want to be able to, if you want to programmatically put data into a queue list, you're going to have to do something along those lines. So let's look at the seq object, or the sequencer object. And the sequencer object in Max MSP is designed to read format 0, that's single track MIDI files. This was the original format of MIDI files, where basically everything is just ordered in the MIDI file from beginning to end, regardless of what channel it's on. Format 1 MIDI files, which are the more common format that you come across when you look for MIDI files online, have each track organized as a block sequentially in the file. And Max isn't able to deal with that format of MIDI file. All right, so basically the way sequence works is that it will is capable of reading or creating a standard MIDI file, reading a standard MIDI file, or creating a sequence from a performance. And you've got a number of controls that go into it, such as reading, starting, stopping, recording, writing, and so on. So let's read a standard MIDI file, format 0. Of course, it has to be in your file path somewhere. I'm going to read the Mozart.mid by clicking on this, and then I'm going to play the MIDI file with a message which says start, and then this 1024 is really a speed control. This basically says play it at the original speed. Stop it. Notice there's a hanging note there. I'm going to flush it out with the MIDI flush. So the sequencer is attached to a MIDI out message, a MIDI out object, which basically sends out any kind of MIDI data. And I put it through a MIDI flush just so I can get rid of those hanging notes. When I stop a performance and a note on has happened, but the note off has not happened yet, obviously there's nothing to turn it off. So MIDI flush keeps track of what note ons have happened. And if I bang it, it supplies the corresponding note offs for those pitches. So almost an essential object. If you don't do this, you're going to have hanging notes and they won't go away until you shut your patch down. All right, so the 1024, if I switch that to something like 512 and click it, half speed. and flush that out. Okay. I'll put it back to 1024. Let's read another MIDI file. By the way, while I play this, you'll notice this MIDI parse object, very, very useful object if you've got either incoming MIDI data from a keyboard through the MIDI in object or a sequence playing. It will actually parse out all the different types of messages, the note messages on and off, the channels, the pitch bends, the control messages, the program changes. All of that will come out, and you can actually track all of the specific elements of a MIDI performance. So I'm going to play this one, and you'll recognize this. Okay. You can see why we need the MIDI flush for that. All right, so there's a second MIDI file. This has got different, different timbres on each of the channels, but it is still in a format 0 format. Okay, we can also record into a MIDI file, into a sequencer, by having a MIDI in object connected to it. And MIDI in connects to a MIDI port, basically brings in MIDI data, and it records everything that's coming in. So velocity, pitches, velocity, channels, control changes, program changes, aftertouch, everything gets recorded into the sequencer. So let me just make sure I've got this connected to the right object, and I will start recording, and I'll just play. And I'll stop recording, and I will play it. Okay, with whatever sound my internal MIDI device is set to. So I was playing it on one keyboard with one sound, but playing it back on a different device. All right, so that's the sequence object. I should mention the MIDI format, because the MIDI format object is really the reverse of the MIDI parse object, where MIDI parse takes a stream of MIDI data and distributes it, parses it into different categories. The MIDI format object allows you to create MIDI messages and put them into a sequence. And it's a rather complicated object. I'm not going to spend too much time with it. If you check these inlets, you'll see that says note on, note off, pitch and velocity. This is going to be key pressure, controller. This is program number, and all of aftertouch, pitch bend, and MIDI channel data. So I've got an argument here 1, so it's going to be in channel 1. But basically, if I wanted to, I could record just some random MIDI data into a sequence by having a random 12 plus 60, we all know that, and having a make note, which is going to supply note ons and note offs, and then program changes. So let me just try this. I'm going to put this into record. I'm going to play a random note, another random note, another random note, and then I'm going to change my program to 1, so it's a piano, a couple more random notes, and then change this to 12, and a couple more random notes. And then I will stop the recording, and I'll play that. Now you have no idea what it sounds like, so you have to assume that it's what I put in there is what we're hearing coming out of it. A wonderful composition. Please don't steal it. It's mine. So So that's just a way of saying, well, if I want to actually format specific MIDI messages and put them into a sequencer, or actually just send them out to my my MIDI out device, I can do that. I should mention that the format of what MIDI format generates and what MIDI parses are actually traditional MIDI messages that have status bytes and data bytes and the channel embedded and so on. So they're not your typical sort of node on, node off messages. They are actually they are MIDI messages that maybe I'll just show you. I don't want to scare anyone away, but let's just, I'm going to put a MIDI format message in here. You can't see it really unless I print it, because we're getting the 3 bytes coming one after another. Let's do that. Let me just move this over and clear this out. Oh, that's what I want to do. Let me just print that. Okay, so this is what we got. We got 144, 60, 100, and then a little while later we got 144, 60, and 0. And 144 is the node on message. The status byte for a node on message on channel 1 is 144. And so that's what we got. If we were sending it out to channel 1, we would get 145. So I know this is a little bit complicated. If you go back to your MIDI format stuff from last year, or again, if you need more help understanding that, I'm happy to help you. But just to say that what we're getting out of here is not a list, but actually the data, the status byte, the data byte, and the data byte, the status byte, the data byte, and the data byte. So it's real MIDI data that's coming out of the MIDI format, and that's the kind of data that's going into the MIDI parse object. And that's the kind of data that comes in, the MIDI in, and goes out, the MIDI out. Okay, enough of the sequence object. I should mention that for assignment 3, creating a sequence is a good way of recording and playing back an exact performance, but it is almost impossible to do the randomized elements of a performance with sequence. It's almost impossible to do that, just because you can't jump around in a sequence very easily. I would say you can't really do it at all. There is another option to the sequence object, and that is the detonate object. And the detonate object was originally designed for score following. It was actually originally called an explode object. Now they changed it to detonate. I'm not sure why they decided they didn't like explode. What a detonate object does is actually creates a file and basically parses all the MIDI data and puts it into a file which you can look at, and you can also move through. So as I say, it was designed for score following, but it can be used for just playing back a file, a MIDI file. So I'm going to read a MIDI file, and I'm going to use the Mozart example. And then I'm going to double click on the detonate object. And this actually shows you the entire file from beginning to end. And all those things you see are the notes that are, and they're colored by the channel that they're on. Okay, and you can go into this, and if you really want to, you can edit them. I shouldn't have done that, but anyway. Don't know if I can undo it. Probably not. Okay, you can edit those, but I wouldn't recommend it. It's pretty fussy. But I can go in here, and I've set this up. The first value that comes out of the detonate is a delay value, and so I can take that value and create a delay line, and then bang the next. So if I hit next, Oh, I have to hit the start button. And stop. Okay? I can also just work through, if I've started it, I guess I can't walk through it the way I can with the QList object. But it is possible to index into the detonate object. So if you look at the help file for detonate, you will find messages. See a rather long, complicated explanation of how you use it. It's an old object. There we go. There's a nice example for that you can look at if you really want to. If you really want to spend the time. Here's the nth. It basically tells you to look for the nth object element in a detonate object. I just wanted to include that as a possibility, as a way of taking a MIDI performance and being able to display the contents and then index into it and play elements out of it. Okay, that's all I wanted to cover with this particular tutorial. There's a lot there. The QList is very important. The sequence object can be quite useful, and it's good for you to know about the MIDI format and the MIDI parse objects and the way they operate. And then finally, just that detonate object, which does allow things like score following and does allow you to index into a MIDI file if you need to. Thank you.